The next one we want to look at is the similar molecule, which is ketones. So similar to aldehydes, it's got a carbonyl group. However, ketones have a mid-chain carbonyl group as opposed to an end-chain carbonyl group. So for example, naming, we use the suffix of -one. So for example, butanone being this molecule down here, we've got 4 carbons along the main chain, so the butane part being the 4 carbons along the main chain, and then butanone saying that we've got a double bonded oxygen on one of the middle carbons along the chain. So the middle carbon along the chain being one of these two, we don't need to name with a number of which carbon this is located on, because it will either be on the second one or the third one, and so the third one would be named as the second one, because if we count from this direction we'd go 1, 2, if we count from this direction we'd get 1, 2, we can't count from this direction because we get 1, 2, 3, and we always want to preference naming with the lowest number. So this molecule would be butane-2-one, but we just name it as butanone because it's always going to be butane-2-one. And so the general structure of these is that we have an R group, so that being our carbon chain, followed by a carbon in the middle of that chain with the double bonded oxygen, so the carbonyl group, and then followed by the rest of the R chain, so that being our R prime group. So some examples which we have of these is like what we looked at before. So we've got butanone, so butanone being our 4 carbons along the main chain, so the butane molecule with the double bonded oxygen on one of those middle chains. The next one we can look at is being propanone, so propanone being our general propane chain, 3 carbons along the main chain making the propane part of the molecule, and then the ketone part being the double bonded oxygen, the carbonyl group, on the middle of the chain of the molecule, which changes this from being a regular propane molecule to being a propanone molecule. Our next functional group we can look at is the carboxylic acids, and so they have a functional group which is called an end chain carboxyl group. And so that is the end carbon of the chain has a double bonded oxygen, so a carbonyl group, and a single bonded oxygen and hydrogen, so a hydroxyl group. And so as we briefly said before, the carboxyl group is the name carboxyl comes from it being a carbonyl group and a hydroxyl group, so combined to get carboxyl. And so the naming for these is we have the suffix of oic acid. So for example, ethanoic acid, this molecule shown here. So we can see the ethane part comes from the 2 carbons along the main chain. Instead, now we've substituted the end of the molecule to have an end-chain carboxyl group, which has changed this from an ethane molecule to an ethanoic acid molecule. And so the general structure for these is that we have an R group, and so the R group is just the general chain of any alkane sort of group, followed by the carbon with the double bonded oxygen carbonyl group, and then the single bonded hydroxyl group, so oxygen and hydrogen, making that end-chain carboxyl group. And so hence that would form the carboxylic acid. So some examples which we have of these is butanoic acid, so that being this one here where we can see we've got 1, 2, 3, 4 carbons along the main chain, and then on the end of the molecule we can see we've got a double bonded oxygen and a single bonded hydroxyl group, making it a carboxylic acid. So hence the butane part comes from the 4 carbons along the main chain, and then the oic acid part comes from the carboxylic acid group, the carboxyl group at the end of the molecule. The next one we can look at is propanoic acid. So propanoic acid being this molecule here with 3 carbons along the main chain, so that being the propane part of the molecule. And then we can see we've got the carboxyl group on the end of the molecule with our carbonyl group here, our double bonded oxygen, and our hydroxyl group, our single bonded oxygen to hydrogen, making this a propanoic acid molecule from the original propane molecule.